This question is about organic reactions. Part A. Compound A is formed when ethanol is mixed with OH- aqueous ions, which act as a catalyst. The balanced equation is shown in reaction 6.1 below. Part 1. Give the systematic name for compound A. The first thing we need to do when giving something a name is number the longest carbon chain in the compound. So working from the functional group, we would go 1, 2, 3, 4. There are 4 carbons in the longest carbon chain of compound A, so that means we're going to use the prefix but. Next, we need to identify key groups in compound A. We have an OH group and an aldehyde group. So in the name, we're going to have hydroxy to signify the OH group. But we're going to have a 3 because it's on carbon number 3. So we'd have 3-hydroxy but to signify the 4 carbons. And then the aldehyde group we show by saying but-an-al, which is the suffix for an aldehyde group. To get the mark for this question, you need to have the full correct systematic name for compound A. Part 2. What type of reaction has taken place? The type of reaction we've seen in reaction 6.1 is known as an addition reaction because there is no other product produced. So both reactants form the singular product, compound A, or 3-hydroxybutanol. To get the mark for this question, you need to write addition on the answer line. Part 3. Reaction 6.1 takes place in 2 steps. OH- ions act as a catalyst. In step 1, ethanol reacts with OH- ions to set up an acid-base equilibrium. In step 2, compound A is formed. Complete the equilibrium for step 1 and label the conjugate acid-base pairs as A1, B1 and A2, B2. Suggest the equation for step 2. Firstly, let's identify the acid and the base out of CH3CHO and OH-. The acid is CH3CHO, so we can label this A1 using the correct labels that we've been given in the question. Our base is then OH-, so we will label this B2. The acid, CH3CHO, is a proton donor, so it's going to donate a hydrogen to OH-, which means we're going to produce H2O and CH3CO-. Finishing the labels, we would have A2 and B1. If we just look back and check for a second, the acid and base conjugate pairs and why they are what they are. So looking at A1 and B1, so A1 means acid number 1. An acid is a proton donor, and we can see that A1 going to B1, well, it's lost a hydrogen or an H+, which is also known as a proton. Then B2 and A2, a base is a proton acceptor, and going from B2 to A2, we've gained an H+, or a proton, and so it has accepted a proton and is the base. And so we can check that we've got the correct conjugate acid-base pairs by using the fact that an acid is a proton donor and a base is a proton acceptor. Now we need to suggest an equation for step 2. So we're told that step 2 is where compound A is formed. So if we refer back to part A, we can see the balanced equation 6.1, which shows compound A being produced. If we label the reactants in this reaction, we have CH2, CHO minus CH3, CHO, and compound A, which would produce OH- ions as well, so we need to add H2O as one of our reactants. If we copy this for part 3 in our answer line, so that would be CH3, CHO plus CH2, CHO minus plus H2O forms compound A, which we can write as CH3, CHOH, CH2, CHO, and OH minus ions. To get the 3 marks for this question, you get a mark for having the correct equilibrium equation, a mark for the correct labels, and a mark for the correct equation for step 2. Part 4. A similar reaction takes place when propanone, CH3(2CO), is mixed with OH minus aqueous ions. Draw the structure of the organic product of this reaction. So, like reaction 6.1, we're going to form a hydroxy group. So we would have CH3 bonded to a COH and a CH3, and then this is connected to a ketone group, and the ketone group would be CH2 bonded to a carbon with a doubly bonded oxygen and a CH3 group attached as well. To get the mark for this question, you must have the correct structure for the organic product of this reaction. Part B. Many organic reactions use electrophiles as reagents. Explain the role of electrophiles in organic chemistry. Your answer should include one reaction of an aliphatic compound and one reaction of an aromatic compound, including relevant mechanisms. There are 2 mechanisms you'll learn about at A level that involve electrophiles. The first is electrophilic addition, and it's between an alkene and a halogen or a hydrogen halide. We're going to use ethene and bromine here. So here I'm drawing ethene, and I'm going to draw bromine, one with a positive dipole and one with a negative dipole. There will be a curly arrow from the centre of the bromine bond to the negative dipole and from the centre of the carbon-carbon double bond to the positive dipole, because the electron-dense region is attracted to the electrophile. We then attach the bromine, and our intermediate will have a positive charge where the consequent bromine, the negative charge, is yet to join. So there'll be a curly arrow from the lone pair on this negative bromine to the positive intermediate carbon. And we will form a haloalkane as our product. Then we're going to talk about electrophilic substitution, which is our second mechanism you learn about at A level. But for this mechanism, you need to form your electrophile. So to form our electrophile, we need to react H2SO4 with HNO3 in this case, because we're doing a nitration of benzene reaction. So we'll form NO2+, H2O, and HSO4-. The benzene ring, the ring in the benzene, is an electron-dense region, and so will be attracted to our electrophile, which is NO2+. And then we'll form our intermediate, again a positive intermediate, where we have a half-completed benzene ring with a positive charge, a hydrogen, and an NO2 group ready to be attached at the end. The hydrogen is re-attracted to the benzene ring, and we form then a benzene ring with an NO2 group and an H+. This is nitration of benzene, but we need to reform our catalyst. Our H+ is then reacted with our HSO4- and forms H2SO4. To finish this question, we're going to define an electrophile. Electrophiles act as electron pair acceptors. This is a definition for an electrophile. It might be a 1-mark question later on in an exam. To get the 6 marks for this question, what we need to do is describe in detail the electrophilic reactions and mechanisms of one aliphatic and one aromatic compound. In this question, we haven't written a long detailed explanation. We've labelled our mechanisms and drawn diagrams of the mechanisms for an aliphatic and an aromatic compound, so it's the same as writing a long explanation.